Hey guys, am I audible? Let's just check the mic situation. Hey guys, am I audible? Okay. Yeah, so in this stream, it's going to be a short stream on. Wait, is the stream on? You can see there is. Okay, those. Give me a second, guys. I'm not sure if you are able to see my stream. Okay, those. Give me a second, guys. I'm not sure if you are able to see my stream. I'll just reduce that. Just give me a second. I'm sure if you're able to see my stream. So mic check. Yeah, so in this video, in this stream, actually, I'm just going to see, we are going to write a Docker Compose generator kind of thing, in Zig. So so the problem exactly we're trying to solve is, so there is a tool called Docker Compose, if you're not familiar, which helps to automate the process of creating containers with some configuration, right? So the given Docker Compose can exist in a single file or it can be however you want. It's just running the command and it picks up whatever the compose file is. And in order to create that single file, that if you're going with single file, let's say if you're going with single compose file, then every service you're going to do is going to be inside that. And the only way you can manage that is to have, you know, have to rewrite the entire Docker Compose, or you have to know exactly what the change is. So it is not organized in any kind of way. So it can have, like, let's say 1,000 services, but the file is going to be one, and that is very hard to maintain. And if it's organized by services, it's a different parts of service. So even if it's different, even if it is in different parts, you're going to when you want to change something, you're going to find that service and change whatever is required. So the problem, not a big problem, but a problem in the sense is that you have to handle everything. There is no single, let's say, platform to handle this, at least to handle the compose file generation. Um, so the file you're going to, let's say, export, or which you're going to use, is going to be the similar one, but we are going to solve the generation part. That is where the Docker Compose is being created or where it's being generated. So that is the thing we're going to be focusing on. So we're going to just write a tool where it's going to create a compose file depending on the mode and depending on other configuration options which the user is going to select. And depending on that, we'll generate a file which consists all of the configuration of the file. So you may ask, like, what is the exact use of this? So one thing is we can try making the configuration much simpler to read than whatever is in the Docker Compose. So if you take a sample Docker Compose, right? Let's go here. So if you, let's take any Docker Compose, for example. So let's take this. So this has all this configuration, right? So there is no easy way to update this. You have to know Docker Compose and how to update this, right? So what we want to do is simplify this, not much of a larger um, concern, I would say, but we can try to simplify the process of writing this Docker file, right? So you can make these configuration options much clearer to the user, so that they can it is the creation of the process of creating the Docker Compose file is much simpler. Let me recheck my stream once. And it is much simpler. Okay. Is it good? Yeah. So yeah, first let me show that. So we're going to have this config file, which is um, not of any language, but it's just a config file. We'll just discuss more on this. And we're going to parse this config file and create some kind of data structure which holds all the information of the Docker Compose file which you're going to generate. And then there is this generation process where we are going to again parse this data structure and then get an output which is a Docker Compose file here. So Docker Compose file or files. Right, so that's the output we are looking for. So at least in this stream, right? So in this stream, so what we're going to do is we're going to set up the repo, and we are going to decide on the syntax of the configuration file. Because we are not going to follow any configuration file, we are going to create our own. Right? It's like creating a new language, right? We're going to parse that using our own parser. So we're going to decide on the configuration file and then start the tokenization process. So the tokenization process, I'll explain this in a bit. So it's basically whatever is in the config file, right? So let's say this is a config file. You're going to see what all tokens, that is words or symbols are there in this. I'm just going to store that in a list, let's say. So this is what I've been coming up with. So let's say this does look a bit simple, but if you ask me if, so what I'm thinking is, so let me show that. So there is a Docker Compose knowledge, right? So there are people who know Docker Compose, right? And there are people who do not know. They are experienced, but they do not have the experience of writing a Docker Compose file. So if you see this, for example, this seems like if I want to learn this, I could have learned Docker Compose instead of this, right? So we must be as simple as, like, let's say services is a list of something like that. That's what we have not decided on that yet, but what I'm thinking is something like this. So a list, we could even parse it in the form of a JSON, let's say. So but we have to decide if that's going to be JSON, because if it's JSON, then it's completely a different problem. We're going to be going from JSON to the Docker Compose file instead of our own configuration file. So let's say we don't do JSON, because if people know how to write JSON, they would have written the Docker Compose file. So the use of this is, like, you can use this tool to just run this configuration file, and then the Docker Compose file or files or any structure will be automatically populated for you. You don't need to do this. What do you say? You don't need to write anything actually. If you ask me from Docker Compose perspective. So what do we do? So let's fixate on the language. The rules are simple. Like, the language must be simple enough. Lesser keywords, or let's say equal keywords as compose. So whatever compose has, we need to do something equal. And if you see here, so if you ask me, right, this everything is just a Docker run command with enhanced flags and options. So there is another possibility that we can ignore Docker Compose entirely, and we can just work on creating a new kind of Docker container manager for Docker. So if we go to the Docker Compose repository, right? Let's just go. Yeah, so Docker Compose is used for running multi-container applications, right? So it's similar. It's just a wrapper on top of Docker. This does nothing. Like this is no way comparable to Docker. Docker is the engine, if you say. So we could create our own Docker Compose, which interacts with Docker socket, right? Let's search for all keywords in Docker Compose. Let's see the compose file. Yeah, there are multiple levels of it. So one is a version. So there are multiple levels. If you see, there is no version level now, but so there is a this is a service level. So each service is defined inside services. So this is that. Okay, let's be simple actually. So let's say language must be simple enough. That's the only rule. Let's say. Right. So if you ask me, so what I'm thinking is for this portainer, let's say the path we can have a path parameter, right? Let's say portainer dot docker compose dot yaml. So the user can give this path in order to you know say where this exactly goes and uh, so what what I'm thinking exactly is that what if we go inside the Docker repository itself, right? Like the compose repository itself, and update this to add this path variable where the that needs the Docker file actually. So that's not possible. So we'll do that here itself. Like we have a path parameter and we're going to create this file in this location, right? So this service goes in this location. For now, let's say we have a container name, just a container name. You know what? Let's not even have a container name. Let's just have the services. So the first, uh, so our first goal is to tokenize this everything. Like, so this is a comment. Let's say we allow comments in this configuration file, and we are going to just tokenize this everything. So we are not exactly keen on getting our syntax done. Mm, so let's say like if, for example, there is this thing, right? So there can be nested fields as well. So for example, if there is a deploy field, right? So let's say for portainer, there's a deploy field. So that will be something like this. Yeah, that goes something like this. And inside the deploy, there is a resources field. And inside that, we have the, let's say, limits. Inside that, we have CPUs. Let's say two. Right? So this is the thing we are going to do. But much simpler than this is something like this, right? Resources slash limits slash CPUs will equal this to 2 and remove everything else. Isn't this much simpler than whatever we were doing? So the slash is going to be um, the nested thing, right? So that looks a bit easier. So if you want instead deploy, there are resources, and at the same level of resources, there's an update config. So for that, you can say deploy slash, if you take this, update config, order. Let's start first. So this also works. So let's see if there's a common so let's say we have deploy slash um, I'm looking for something like, let's say, test here, something, it doesn't matter. So there is a common path here, right? So for this, we can even do like this, something like this. So what I'm saying is, we can do something like this, is what I'm thinking. So deploy slash test is a common one, right? So it will be something like this, and inside that, we can have this, right? So deploy slash test slash resources this and slash update config. So this is also possible. Right, so for example, we'll just remove this because we want to just demonstrate that this is possible. And so there is a list. So for example, there's a depends on, right? So we can do depends on. We can do a list, Redis, and let's say database. So there's a list, right? So the good thing is that we don't need to check actually if there's a dependency, because all we are going to do is to generate a Docker Compose file. So the user has to be careful of doing that, because we are in no way, our job is to just generate the set version of the Docker Compose file. So we're not going to do anything other than that. Let me check the live stream once. Yeah. So yeah, I think we can get started with this. At least the syntax is fine. So whatever, I don't think other than this there's anything left here, because everything just comes under this syntax. There's nothing new here. So there is, for variables we want to be doing this. There are no semicolons, anything. There are no commas. It's just line by line, right? So so they're going to be just this open braces thing to show that this is inside this. So everything is belonging to this and this. So something like that. So there is a list field and there's a string or number field, whatever this value type is. Yeah, so there can be multiple services like this. They can be put in at 2, and there'll be no commas anyway. We're not going to do commas anyway. I think this should look good. Um, if you ask me, this looks much simpler if you want to deploy this and generate the Docker Compose file. But if you want to update anything, I can just do it here. Okay, let's. This is the syntax, and keywords are there. It's there. So right now, what we have is a compose config file. Let's put that here. The example file as well. So all we have is the main file right now, and let's remove this extra code. So please keep in mind, I'm not sure with how Zig exactly works. I'm pretty new to it, so I am also starting to learn that. Yeah. So the next job is to, so we haven't set up the repo, right? Let's set up the repo. So let's create a repo and keep pushing whatever we do to that repo, and you can just check. I'll just put the link, and then you can check that repo if you want to really, get the code or something. This is going to be compose generator, I guess. Let's put a description, generate, compose, YAML files via a single config file. I think we have to even rename this to composer to What did we call that? Compose generator. And does this run? I think this runs. Yeah, so let's just initialize it. You know what I'm going to do? I'm going to copy this config to the previous one. So if I go back, I can just remove this and just say zip. Sorry. I can do npadi compose generator, and then I can do zig in it. It one. I can have to go into that. I can do zig in it, and then I can go back and say compose.config here, compose.config.example here, and if I do, so let's create a make file. So I'll just create a make file here. We're going to have run. We're going to have b run, which is build and run. So build and run. It's going to be zig build, and where is it? So if you just see here zig build, right? If I do zig build, it creates a zig out folder. Let's see. If I go to zig, there's a zig out folder. So zig run is going to be zig out slash bin slash compose generator. It's going to be just zig out slash bin slash compose generator. So now I can go back and say make b run. It should build and just run this. So this is actually okay. So this is an automatically generated one if you want to see. This is what Ziginit gives me. So if I go, I can even do test. Do zig build test. Let's do make test. So it's building and then testing. Yeah. Wait. Can I do zig test? Okay. Yeah, I think this looks good. What I'm going to do is I'm going to remove everything. I will remove these things. I need the import, std import anyhow. Do I need this? I'll just remove it. Yeah, let's do standard.debug.print hi. So every time we do something, we need to build and run. So we're getting the hi. So it is working. So let's initialize the repo here. Let's init remote add origin, and then let's add this. So let's add a git ignore here. Git ignore, and what we're going to do is we're going to add zig out compose.config. You know what? I don't think we need the example file. So I'll just notice it. I think everything else can stay. So I'll add everything and I'll just comment. First comment, add zip report. Wait, is zip cache going on? We have to do the upstream. Okay. Let's push it to main. Let's push it to main. So that should populate this repository here. My internet is a bit slow. That's the reason I keep checking the stream as well. I think it's because of my VPN here. Let me switch this off. It's canceling to shut in. Why is it so slow? Is there anything heavy we have? Wait. Oh, sorry. In the meantime, we can go and try doing what we want to do. Let's do that here until then. So what we want to do is let's actually see what is the zip folder structure. Let's go to Ghosty. So Ghosty is the terminal emulator written in zip. Let's go and check the structure. So we have package. So it's also binary, I think. This just have a package here. So there's src. So if you go to config, wait, if you see the make file, I think it should be easy to understand. Yeah, so init. Yeah, it's pushed. Let's come back. Make B run to populate the zip cache. And let's go inside this. Let's go to main. And now we are going to organize our structure, right? So the first thing we need is a tokenizer. So let's say the first thing is that the source comes in, right? Source in the sense one in the compose.config file. This comes into our application. So what we're going to do is we're going to tokenize this. So tokenize in the sense we're going to split this into parts. It doesn't make sense, but let's say for this, it would be something like source, and then what? Sorry, services, and the next one is in open brace, and the next one is container, next one is open brace, and so on. So this is exactly what our compose file, sorry, the config file is of. We just break it into single words and store those single words here. And when we are trying to build a tree or build a data structure on top of this, we have to go through each word and see if it's meaningful or not, right? So if it makes sense. So that's what the tokenizer is going to do. And then generator is something. From tokenizer, we want to generator. At least we generate this, right? From the tokens, what we give is a, let's say, DS. Let's say kind of an AST, right? We give a tree, generates a tree, right? And then we parse tree. If you parse a tree and the output is going to be star slash compose or YAML files, right? So this is what is going to happen. So for this, we are going to have we're going to break our code into different pieces, like different. We're going to just structure it, right? Okay. So if I refresh this, I think I should be able to get the, yeah, right. So how do I structure Zig? Is there any way to do that? I know, like if I can just put a folder, right? Let's say tokenizer here. tokenizer, parser, generator. Right? So these three will have their these things. What do you say? Files. So for example, in SRC here, let's say we have terminal here. Inside that, do we have a main or something? How many mains do we have? Yeah, we have a main here. Okay, this just imports this. Let's say we have kitty.c here. Let's go to Gemini and ask it how to structure the folders. I'll just ask that. I mean, it is very slow. I think SRC is something we can do. So inside this, we can have a main.zip, and then let's ask this. Okay, in SRC we have a main.zip. Yeah, that's how we do it. Okay, I think we can import whatever we have from this. So let's say tokenizer.zip. Okay, so we have, let's say we have a simple import, and we have a simple function, right? Let's say tokenize. So this just says debug.print. Actually, what it says here, it just says file, let's say tokenize. And I can just pull this here, right? Tokenizer. It's going to be import tokenizer slash tokenizer.zip. And then instead of doing hi, I can just do tokenizer dot. I think I have to make that function public. How do I make that public? Yep. So now I can do tokenizer dot tokenize. And if I try doing make run, wait, what? Union is ignored. Okay. I have to do. I think either I have to do try this, or I can remove the try here and remove this here. Yeah. Yeah. Actually, let's do the. Let's handle error. So let's do try. It works. So um, so what we're going to do is we're going to um, so first thing is we need to read a file, right? So what this tokenizer is going to do is read the config file first, and then parse the config file, populate the um, list. So that's what we want to do. You can give the path name to the config. For example, I can just say compose. Is it dot slash? It's, yeah. So I can just give the path here, and then I can just say path. Is it a string? Okay. Okay, it's U8 at path. I can do this. I can do path. How do I typecast this? Yeah, this should be working, right? Okay. Const path is something like this. And I can just take the const. Can I do const? Okay, I can do here, right? Okay. Yeah, that works. So that works. So at this path now, we're going to populate a data structure. So we need a data structure to hold everything, right? So let's say, what are we going to say? So we're going to create a struct. Let's go to the documentation and see what struct it is. Yeah. So we can say, okay, we need this. So let's call our struct like this. Let's say, uh, if you can see this, where's the struct? Yeah, this is what we're looking for. And so let's name our struct, which is going to be tokens, right? So it's going to be a struct. It's actually going to be a list of structs. So let's say something like this. The token is going to have a value, and that is going to be a string. There's a comma here, and yeah, that's the token has a value, right? And now I can say let, is it a let var? So it's a var. The tokens. How do we create with the type? How do we append the token? Is let's actually go to this, and let's say Ada. We have this. Let's going to ask mode, and we can ask to our LLM now how to use list or arrays, I guess. Let's see. Um, okay. Hey, did I close the tab here? Um, it's HT, right? Okay. So like we want 1D array. So we could do this. Right now, what we want is, what is it? So let's do this. Can I do tokens? There's no append or anything. Or push. Okay, I can just do this. How is it possible? Okay, I think we are looking for vector or something, right? How do you know what the length of the tokens are? Vectors and zip. So that should see. So how do we do dynamic arrays instead? Okay, there is something called an array list. array list type is going to be this, that tokens is going to be this. Let's do this, tokens dot append. Wait, wait, okay, there's a separate concept for I actually don't know. Let's check. Okay, we have the array list here. Append. Okay, do I not need this? List of struct and append. I'm pushing one array list. Okay, let's ask for array list of struct. Before that, we need to initialize this allocator, right? Okay, let's say let's pass around the allocator as well. So I guess if we are going to do that, what we can actually do is we can create a struct. Let's say tokenizer, right? It's going to be a public uh, tokenizer, and we're going to say what we're going to say. So let's say tokens. It's an array of token, right? We want to do it like that, and then this also has the allocator, and this is going to be, if we go to the main bit, let's create an allocator here. std.heap.general purpose allocator. And for the tokenizer, we want to wait. Let's do this. Let's create a tokenizer where tokenizer is equals to, yeah, okay, we have imported that dot. Where is the node? Where is this one being exported? Not sure what is happening, but okay. For now, let's allocate this directly here, right? And okay, you can do this. So here, so does struct have functions in the, so let's see structs. Okay, there's a function inside this. So we can move this into this. Right? So this is a function we're going to have, and the allocator is going to be, wait, what type is that allocator? Okay. So this, what it's going to return is the question here. Let's just do history dot keep dot general purpose allocator with alloc in this is going to be this dot. How do we do this dot? Need to allocator or no? So I think we can give the self here, right? How do they do that? Okay. Let me tokenize it, right? And I can do self dot allocator. That's okay. I mean main zip, right? If we are doing tokenizer dot tokenize, we're going to do is a struct. I'm going to create that struct and then do this. Let's actually try. I'm not sure if this works. Okay. There's a function which returns. What is the type? You know what? Let's do this. Let's silence this. You don't want to do init then? You can just do this. Yeah, we got the allocator, but what is the type of heat dot general purpose allocator? And can I pass it around functions? Let's ask this. What is the type? What is the type? We have Twitch. So if you're not watching on Twitch, sometimes do give a watch. I just started streaming on Twitch as well. I think the feed is coming in, so yeah, you can watch. We got the debugger here. Okay? So let's, you know what? Let's just keep it this way. And for token, I think we can just do this. Okay, we need the self done. Right. So we can do this, and then we can say this is what um, yeah, I think this should work. So right now we don't have anything to be done, but we got the thing ready. So we're ready to tokenize this, right? So let's say we're passing this and we got two tokens, right? And then main as well this. Okay. This is tokenizer. We can update this to a better name. Update this to be a better name. So we're going to do this. Um, yeah, so let's try adding a couple of tokens to this. Self dot tokens, let's say. Let's add self dot tokens dot push. How do you add to an array list? Okay, let's get the let's we have to rename this to GPU. This will be allocated. Let's put this here like this. So how do I push to this array list? That's the question. Without append. Can I do it append? Okay, this is array list. It's going to be an std dot array list of type token. Right? Now I can do dot append, and this the value is going to be, let's say this dot value is going to be what? Um, can I do this? Come on. Wait one. I have to go back and comment. Now I can do it again. Slash ask slash add tokenizer. What? Yeah. Then how do I do this? So I can do src slash tokenizer slash tokenizer dot save. Yeah. Now I want to ask um how to call the tokenize function. So yeah. Okay. So I guess we need to do the allocator thing there itself in the main, because let's say we are allocating this here. I have to actually study on this. I'm not sure how this allocating thing works. So let's defer dash equals to dpio.dinit, and then we get the allocator, and then we create the tokenizer. So let's remove this, and let's say const tokenizer is, wait, tokenizer dot tokenize should be working, but so in this the tokens is going to be a field, an array list of allocator. Okay. Okay, where does the token come from? Okay, that's a type. So dot init. So token I think should be here. It should be this. I think it's not public yet. Let's make that public. So this would be tokenizer dot record. Why is this even after changing the pub doesn't work? Import token. That's what I wanted to do. Is it taking this much time? It's taking too long. Okay, even if I make it public, right? And importing, I guess. So this is just importing the tokenizer. Import the token, I think that's a separate thing. So now I can allocate this. And with the path, I can say tokenizer or tokenize the path. That should work, I guess. Tokenizer. So we will need to define this. Wait, we declared this, so what is the problem here? Expected type is this. Okay. Is this something with the allocator? So what file is it? Name.zip. What are we getting? We're getting this. Let's get this. Okay. Use the van. Okay, it needs mutable. Why is it so? Again, I think I need to do try. But it should work, isn't it? So dot value is going to be so this. Yeah. So I know that we are expected is that we're doing that. Should we give const here? Should we make this const? So to append even that, okay. Actually, that is good because now we are making sure that we're handling that. Okay, I think I'll put the tokens. I don't know. I'll just put any and here. Let's put this alpha tokens. Okay, so we have 1, 2, 3. Yeah, that should be fine, I think, because without this should be. I think that should be good for today. I'll just comment this. Feed add tokenizer module draft. So I push that. So yeah, I think that's it for today's stream. In the next stream, I think I will finish the tokenizer, and I think we'll just get started with the next steps. I think the tokenizer might take the next entire stream because we need to find all the edge cases, right? So the next stream is going to be about tokenizing and how we're going to parse that into the tokens, right? So yeah, and we are going to store that in this structure, not this, yeah, the tokens. So each word is going to be a token. So that's what we're going to be do in the next stream. So yeah, need to leave now. So see you guys. Bye.